Hey guys, Jason here with AVPro Edge and Meridio, and today's a very cool day. We're going to be talking with a very special guest. We're going to be talking all things fiber with HDMI 2.1 and 48 gigs being right around the corner. Fiber is obviously going to be a very popular way to build your infrastructure for your AV system, whether it's a residential or commercial environment. So again, my name is Jason. I'm with AVPro Edge and Meridio, and let me introduce Gary. Gary, go ahead and switch your screen.
Hi guys, just share my screen here. All right, hi guys. Yeah, thanks Jason. My name's Gary Vlaeminck from Clearline Fiber and also AVPro. I work independently and help both AVPro and Clearline primarily with their overseas efforts. I live and work out of my office in Pennsylvania, but travel a fair amount overseas and help expand our horizons into foreign lands where they're beginning to adopt fiber, just as we are here in the US. But I also cover a lot of the East Coast as well, predominantly for Clearline, to help really, introduce integrators and dealers to the subject of fiber, because frankly, AV hasn't really needed or had any purpose for fiber until recently. Fiber's been around since the 50s and 60s, so it's been around a long time, and fundamentally it hasn't really changed. But we've never really needed it. As far as bandwidth is concerned and distance, point-to-point audio and video distribution has always been able to be done or achieved by either speaker cables or twisted pair when we went digital, or even copper cables before that, with RCA and BNC connectors. But now, in particular, with the advent of high definition video and all the other neat features that come with HDMI 2.0 and beyond, we've kind of exceeded the capacity of copper, and so we're now looking at fiber infrastructure as being the medium that can help us, from now on through that transition of technology. And so it's my responsibility really, on behalf of both AVPro and Clearline, to help dealers to, first of all, understand why they're even talking about fiber, but secondly, to kind of educate them and bring them up to speed with what fiber is all about, how it's made, how it works, and some of the endpoints that go onto the end of the fiber. So that's who I am, and that's what I do, and I'm happy to be here today with Jason talking about these things with you.
Nice, thanks, Gary. So interesting story. Something happened to me recently. I was at a friend's house. They just built a house. It was brand new. And we were walking around and looking at all of the endpoints and looking at where all the cables for the house were ran. And it's late 2018 at this point when the house was built, and the house was wired with Cat5 and coax. And I'm thinking to myself, what a missed opportunity, because if this particular person is okay with just 1080p and standard dynamic range video, then the Cat5 cable will be okay. But this poor guy just bought this brand new house and had it all pre-wired, paid the extra money for the pre-wire. And it was just sort of disappointing. Like, why not fiber at this point? Especially with 4K and HDR, we're just scratching the surface with fiber. We figured out some clever ways to still use category cable for HDR and 18 gigs. But at CES this year, we saw plenty of HDMI 2.1 products that puts us at 24 and even in some cases 48 gigs. So, what I've been saying for the past year or so at least is, if I'm buying a home right now or building a home right now, I'm going to go ahead and pre-wire it with fiber and get it out of the way.
Sure. And here's the thing to remember. We're talking right now about devices needing to compress, 18 gig down to 10 gig. So you hear everything, you hear in the media and in the spec sheets about everything being 18 gig compatible. And frankly, that's what it is. It's compatible with 18 gig. But in order to get it down a twisted pair, whether it's a Cat 6 or Cat 6A, it has to be compressed down to 10.2 gigabit per second in order to pass through that copper infrastructure. So yes, things are able to be made compatible with 18 gig today, but they're compressing, almost a 2-to-1 ratio from 18 down to 10 in order to get it through that copper pipe. So today it's quite achievable, and there are some really cool devices out there. Not least of all, obviously the AVPro devices that deploy ICT, the invisible compression technology, where it's almost invisible to the eye and even to test equipment when that compression occurs. But, we're heading into an era now where we're going to go from 18 to 24 to 48 gig and beyond. And those compression techniques are going to become, really, really difficult, if not impossible. If you're talking about 48 gig with the full deployment of HDMI 2.1, we start talking about compression ratios of 5 to 1, which is a lot different to the 2 to 1 ratio that we're talking about today. So you're absolutely right. I mean, the movement of technology and the introduction of different characteristics within HDMI going forward has really just pushed us beyond everything that copper can kind of handle.
Yeah, it's always interesting to me too, especially when the word compression comes up. I've been doing this a while now. I've got a very picky eye. I tend to, I'm kind of the guy in the theater pointing out all the things wrong with the picture, and that's just how I'm built. And with the ICT technology, you're right. It is almost invisible to the human eye, but for people who, like me, might consider yourself a videophile, or if you just want the best, the only way to do it, the real way, is uncompressed. And the only way to do that with 18 gigs right now is to go fiber.
Sure.
So let's talk a little bit about what makes fiber so great over copper. I mean, we know that there's more bandwidth. There's things like electromagnetic interference that we don't have to worry about with fiber. It's obviously going to be faster. It's tougher. You can yank on it harder and stuff like that. So from your perspective, working with the Clearline stuff especially, what are some of the biggest benefits that you've come across using fiber so far?
Well, yeah, I mean, you've hit on a good couple of them. Everyone automatically assumes that fiber is just good for bandwidth. That's kind of the buzzword when it comes to I need more bandwidth. But it's also good for deployment of an infrastructure over a long distance. If you need to get beyond the capabilities of the standard HDMI copper cables or AOCs, even the active optical cables that utilize fiber within them. If you need to go beyond that 100-meter mark, you really do need to start thinking about a bulk fiber infrastructure to be able to transfer those signals properly. So, you've got the distance, the bandwidth. The bandwidth capabilities of fiber can far exceed what we're talking about today in the way of 48 or even further beyond as far as bandwidth is concerned. But like you mentioned, I mean, we've got the peripheral advantages as well. For those of you that have installed twisted pair infrastructure into a building, I'm sure you've run into the experience of commissioning a system, making your displays all look very, very nice and calibrate them properly. And then another trade comes in the door, and they might install the microwave in the kitchen, or the homeowner might come in and bring a baby monitor or something like that. Or in a commercial application, you might have elevators or lift shafts or things like that. And they're all going to induce a lot of EMI and RFI and general electromagnetic noise. And of course, a twisted pair cable, unless it's been properly run and away from all of those high voltage cables, they can potentially pick up that noise and cause the displays to be compromised and the picture to be fuzzy or glitchy or pixelations and things like that. So there's all kinds of things that can go wrong with the induction of electrical noise onto a copper-based system. So being that fiber optic is made of glass, and it doesn't have any copper in it, and it's a transmission of light, we don't have these issues. For those of you that live around the coastal areas, it doesn't corrode. All right, if you're in an atmosphere which is very salty, for instance, fiber optic cable doesn't corrode. If you happen to be in an area which is particularly prone to lightning strikes or storms, again, the opportunity for damage to occur through a fiber optic cable is reduced considerably from lightning strikes because there's no conduction available. So it has a lot of peripheral benefit to it, as well as just the obvious, bandwidth and distance capabilities that come with it.
It's actually an interesting point you bring up. I've never thought about that before. Me being a native Floridian, I've worked in the AV world now for years and years, and I can't tell you how many times I've seen a lightning strike take out a TV over the HDMI. That's
sure.
actually a great point. And also with the corrosion, I didn't think about that either. With being here right by the ocean and whatnot, all that salt in the air can eat away at some copper for sure.
Well, yeah, I mean, fiber optic has actually been used with a lot of the higher end marine dealers. A lot of the super yacht manufacturers have been deploying fiber for years, actually, primarily because it takes up less space than copper.
Sure.
It's able to carry the bandwidth. And so they've kind of future-proofed well in advance, because super yacht together, it's really difficult to kind of open up the hull and start rewiring it.
Right. Yeah.
And B, it's permanently exposed to a very corrosive atmosphere. So even though the environment may be controlled within the yacht itself or the cruise liner itself, it's always going to have some exposure to that corrosive salt air. And of course, that causes corrosion. So yeah, fiber optic's been used in the marine industry for a long time.
You make an excellent point that it's a lot smaller. So let me ask you this. If I had a 500-foot spool of fiber and a 500-foot spool of category cable, which one weighs more?
Oh, the cat cable by far.
Yeah.
It's kind of funny. I always remember the first time I picked up a 1,000-foot spool of fiber, and I almost let go of it because I picked it up as if I was picking up a piece of Cat 6 or Cat 5, and I nearly threw it up in the air because it's just weightless.
So smaller, lighter, easier to work with. It's more reliable in difficult environments. When you mentioned before with the EMI interference, I'm thinking of like even a commercial environment. Maybe it's a restaurant with a lot of electric motors and the refrigerators and all the cooking devices and things like that. That is just asking for problems when you're running copper. So situations like that, if you're going over a kitchen in a home, fiber just sounds like it'd be the ultimate solution going forward. And that's also including the bandwidth and the faster speeds and all the other stuff you mentioned too.
Well, it is. I mean, we're going to start talking about Clearline in just a second, but historically, legacy fiber has been fairly difficult to work with. It needs a very precise preparation in order to terminate properly. People out there may have heard of polishing puck or having to clean with alcohol, having to fusion splice and things like that. So there's all kinds of horrible history that comes with fiber. Really, bend radius, you can't bend it very much. You can't pull on it. You can't tread on it. So it's very fragile. I mean, you're talking about an infrastructure of product that's made of hair-sized glass strands. I mean, it's very, very fragile.
Right.
However, when we start talking about Clearline in a second, we had the foresight to recognize that the AV industry is going to be new to fiber, but it's going to be necessary at some point. So the engineers at Clearline made it easy to terminate. They made it safe to terminate. It cannot puncture the human skin. They made it quick to terminate. They made it easy to pull. They made the amount of tooling that you need much less. You don't have to buy thousands of dollars worth of tools anymore. And they made it such that it's very easy and quick to terminate in the field. So even with just 15 or 20 minutes of training, I can get a dealer that's new to fiber infrastructure. I can get him out there and terminating fiber in no time with no specific training on how to handle the fiber or how to route it around or route it, as you guys would say, route it around copper cables and other infrastructure within the building, which as a legacy infrastructure, fiber obviously had to have all those considerations taken into account.
Well, it sounds very, very integrator and installer friendly, which is probably why AVPro partnered with Clearline in the first place. Our goal is to make installers' lives easier. And if this is making the installer's life easy and we're able to get all the benefits of it and you can terminate it in the field and it's inexpensive compared to what it used to be, it just sounds like a no-brainer at this point. I mean, I remember in high school, so we're talking like late 90s, they were laying fiber through my neighborhood and they had this tent out there and a guy was wearing like a hazmat suit. And so when you start talking about terminating fiber, it does sound intimidating and kind of scary at first. So a lot of integrators might be apprehensive, but I've done it a few times myself and I've seen you do it plenty of times. And it can be done in a minute or less. It's easy, no special gloves or hazmat suits or anything like that. It's nice and safe. And the cable itself seems like it's not expensive anymore. We have these kits available that are not expensive anymore. This really should be what people are considering going forward.
Well, yeah, you're absolutely right. The cable itself has come way down because there's more of it being deployed now. The tooling that's involved for terminating clear line fiber has been reduced down to a very minimal amount. But more importantly, the endpoints which go on the end of the fiber are becoming more affordable too. I mean, it wasn't so long ago that we were looking at $2,000-3,000 for a set of HDMI extenders over a fiber optic cable. Totally. That same set of extenders now, after a couple of years, is back down to $500-600. So the disparity in price cost between copper-based extenders and fiber-based extenders has really become quite minimal.
Good. That's good to hear. So, Gary, where do you want to start with fiber? Do you want to start talking about the OM ratings? What do you have in mind to start with?
Well, let me try and share my screen here. If I can bring up a PowerPoint. All right, cool. So, what I want to do really, first of all, is start talking a little bit about that bandwidth thing, and then we'll go into the fiber and its makeup and how it works and stuff like that. So this chart was originally given to us by AVPro, so Clearline is allowed to use it. And it really kind of goes through a lot of what we've already spoken about this morning, kind of given an idea of the required bandwidths for HDMI version 1.4 all the way through version 2.0 and beyond, where we start at just a couple of gigabits per second with a basic 1080p signal with 420 color compression. Obviously, back then there was no HDR, no high dynamic range to consider, and the color gamut was very narrow as well. We didn't have that nice wide color gamut, so we really didn't need much bandwidth. But as you start going through the generations of HDMI and they started improving resolution and frame rate speeds and things like that, you can see we very quickly get up to the 8.9 or 11 gigabit per second. And that's the threshold at which you really need to start either considering deploying fiber, or you're going to be adopting some kind of compression. So anything below that line that you're looking at here really is going to be, either compromising what the native picture could look like, or it's going to be you're going to be needing to deploy fiber. I just wanted to bring this up. I find this to be a very useful chart to kind of explain, where the cutoff point is, and this is actually a good chart also for you guys out there, for dealers to explain to their end users, the homeowners. If you expect to get this type of delivery of picture from your device or from your display, we really need to start talking about this type of technology behind it.
There is something that stands out to me here. I've got some real world experience with this. If you look at the very bottom line, that's 4K 60, HDMI 2.0, 2160p, 60 frames per second, 444 color, 8-bit, with HDR and with wide color gamut. That's only 8 bits. We want to be 10 at least for HDR, right? So there's one movie right now that off the top of my head kind of fits these parameters. It's the Billy Lynn's Long Halftime Walk. It fits all these parameters. One thing that makes that movie so special is that it's on disc, at least, it's 60 frames per second. So if we keep the 60 frames per second, we run out of bandwidth when we try to go 10-bit. So that's why that bottom line is 8-bit. So the point here is that something has to be sacrificed when we want it all. We can't have it all right now because we don't have any bandwidth after 18. And if we look at that Billy Lynn movie, 2160p, 60 frames per second, 444, 8-bit HDR wide color gamut, it's 17.82 gigs. So we're already at that ceiling of 18, and it's only one movie. We got plenty more movies coming out with high frame rate and stuff like that. And of course we want to be 10-bit if possible. We don't want to rob any color, and we want to keep the 60 frames per second, especially if that's how the movie was made. So something has to be sacrificed. And in this case, it looks like it was the bit depth went from 10 to 8. So what that means to the picture at the end of the day is you might have some banding in solid colors and in the sky and things like that. So as we move into HDMI 2.1 and we have more bandwidth, then we can finally have everything that a movie like that has to offer. So this is a great chart. It's very, very helpful.
Right, right. And not only is the content now becoming available, but the displays and the projectors out there are now able to reproduce that content in the format it was intended.
Absolutely.
So in order to deliver that to the sync device, the display or the projector, you've obviously got to have the infrastructure behind it to do so.
Good. Very good. Awesome. That's a great chart.
So let's talk a little bit about fiber and what it is and how it works and what we're actually talking about here. As it says here on the slide, it's a bit like talking about plumbing pipe. Basically, you have a tube of glass down which a beam of light shines. And now in the case of single mode fiber, it's a very, very small tube of glass around which there's a slightly thicker tube of glass around that. And it's just got one beam of light going down it, a single mode of light, if you will, that shines down it. Single mode is not to be confused with single strand. Single mode could be multiple strands of fiber, each with a single beam of light going down it, or back and forth down it. So, you can see from this chart, it's got a 9-micron glass core. Now, 9 microns is 9/1,000,000th of a meter, for those of you that are trying to figure out what a micron is. 9/1,000,000th of a meter is almost invisible to the eye. In fact, it pretty much is. Now, around that, the 125 micron glass cladding, that is what they call a doped glass. It's a glass covering that goes around the core that has a different refractive property to the core itself. And what this does is causes the light to bounce down the core as opposed to out to space. So it's a bit like when you're playing golf and you hit the ball in the lake and you go and fish the ball out of the lake with your golf club, and it looks like the golf club is being bent. That's because the refractive properties of air are entirely different to the refractive properties of water, and so that's why you get that bending effect or reflective effect of the water. And it's very similar here, right? So the refractive properties of the cladding are completely different to the refractive properties of the core, which allows the light to bounce down it and not straight out to space. So fundamentally, that's the way a fiber optic cable works. And in the case of multimode, that inner tube becomes a lot bigger. And by much bigger, I mean 50 microns instead of 9. So still realistically the size of a human hair, again with 125 micron cladding around it. But this time we're able to send multiple beams of light or multiple modes of light down the same piece of fiber because the aperture of that core is a great deal bigger. So we can kind of bounce light down it in multiple formats. So single mode versus multi-mode. Generally speaking, guys, I think for those of you that are listening to this video, you're going to be primarily looking at multi-mode. The reason I say that is because multi-mode is generally used for distances up to about 1,000 feet or 305 meters. Multi-mode devices are what's commonly used within the AV space. The AVPro, both the compressed and the uncompressed fiber extenders, which we'll talk about in just a second, they can use either multi-mode or single mode, but most of you guys are going to be using that with a multi-mode type application because it's just going to be point to point, up to a relatively short distance compared to what single mode could do. The use of single mode versus multi-mode is really contingent upon the hardware you plug into it. So we've got some very clever guys at AVPro that have designed a piece that can actually take both. But a lot of the time you'll read on the hardware that you're plugging in, this is a single mode device or this is a multi-mode device. It won't be compatible with both. The same with the type of connectors you're using. These are multi-mode connectors or single mode connectors. So one is not compatible with the other as far as a fiber to fiber connection is concerned. It's the hardware on the end that's going to dictate to you whether it's one or the other.
So Gary, from my own knowledge, I'm curious about something. So obviously when the signal is traveling over HDMI, that's going to be electrons and copper. When it's traveling over fiber, it's going to be photons and light and glass. So what part in the extender kit, whether it's the transmitter or the receiver, or maybe one day the fiber plugs straight into the television, we'll see. But as of right now, what piece in the system is actually converting the electrons over to photons and vice versa?
All right. Jason, it's this device here. It's called an SFP, or a small format plug. Basically what it does is it takes electrical input on the one side and it gives out the light output into your fiber optic cable the other side. And so you'll look at if you're using this for like network switches and things like that, you generally have a bank of 24 or 48 RJ45 ports on a switch. And then you've got these goofy looking holes on the end of the switch, which nobody really knows what they're for. It's for this guy. It's for the SFP, and that is going to, as I said, that's going to convert the electrical pulses to light on the output, and literally just use two what they call LC connectors or little connectors. It's actually Lucent, but LC connectors to transfer that light down the fiber optic cable. So yeah, to answer your question, is this guy here? It's the SFP, and this is fundamentally what's available in format that can go into a network switch. It might be a media converter that converts a single port of copper to fiber and then back again, almost like an Ethernet equivalent to an HDMI extension piece. And then of course you've got the HDMI balance or the HDMI extenders that we produce, which have these connectors in them as well.
And this is interesting because this SFP piece, it looks like it's obviously not part of either the receiver or the transmitter. This is something that you can remove from the body or the chassis, right?
You can, and if I get close to the camera, you might be able to see some numbers on there.
Yeah, we've got 1.25G SFP, 1,310 nanometers, 20, I'm guessing kilometers, 20 km, and then DDM, and then there's like a class rating on the bottom. So yeah, there's a bunch of data here. What does this all mean?
Well, so the 1.25G is 1.25 gigabit per second. So this is actually a very, very inexpensive, low-grade SFP, which I'm using just to demonstrate here. But the other numbers, the 1310 nanometers, that immediately tells me there's going to be a single-mode fiber that goes on there, because single-mode operates at 1310 nanometers wavelength, whereas a smaller wavelength number of 850 would be a multi-mode wavelength. But you can see on here, just to give you an idea, it says on there that 1310 nanometers and 20 km. That means that this device here is able to send 1.2 gigabits of data over 20 kilometers of distance. Right, so this guy is a very powerful unit in some ways when you start talking about distance. Unfortunately, this one is actually a relatively inexpensive one and can only do 1 gig, 1.25 gig. But now you can get these SFPs that can go to 10 gig, 40 gig, and they're even there are 100 gig SFPs out there. They get fairly expensive. But you can tell now that as we start going into the realm of fiber, we're only just touching the tip of the iceberg as far as bandwidth and distance is capable.
Yeah, 20 kilometers. That's insane. That's a long distance.
Sure. Yeah,
that'd be like if you were sending signal from. I'm having a hard time even coming up with a good example. I mean, that'd be maybe wrapped around a stadium a couple times, even, right?
Well, generally speaking, single mode, like I said, is used for distances beyond 1,000 feet or so. So anything beyond that, you should really be looking at a single mode. It's normally used, building to building,
right,
or between floors on a high-rise building if you need to get the network up to the high floor of a high-rise building. Mm-hmm. But single mode is also what they use, for the infrastructure of the cities and the roads, and even under the oceans as well.
So that cable that's under the ocean, that's a single mode, of course.
Yeah, that's going to be single mode. Yeah, for sure.
There was something came up recently with one of our customers, and this actually is a great use case for this. The homeowner had a camera out by the mailbox, but this guy lived on like this huge piece of property. So they ran single mode all the way down to the mailbox for that camera down there, because it was I can't remember the exact distance, but it was more than a mile.
Sure. Down
to the gate in the mailbox. That's a good use case for that. Cool.
Well, I actually have a slide here. If I can share my screen again.
Sure. Go right ahead.
All right. So this kind of talks a little bit about. This is actually just for multi-mode. So, like I said, single mode takes distances and bandwidth even greater numbers than this. So for multi-mode fiber. We have different grades, and they're known as OM1, 2, 3, and 4. OM1 is kind of a little bit obsolete now. Still out there, but a little bit obsolete. But you might like to consider OM1, 2, 3, and 4 as in legacy terms as Cat 3, 5, 6, or 7, as I note to the left-hand side there. So, but you can see the bandwidth and the length of capabilities of fiber, far exceed the capabilities of twisted pair or conventional HDMI cables. And you can see here, for those of you that have been doing AV over IP, for instance, a lot of people are trying to get 1 gigabit per second over a network, because those networks are still very, very affordable, and they don't really require fiber. But If you want to get latency free and a higher quality video over IP, they talk about the 10 gigabit per second infrastructure that needs to go in. And as you can see here, we can very easily do 10 gig up to 300 meters with an OM3 grade fiber, or even greater distances if necessary with an OM4. So you can see here that also on the far left that we can do 40 and 100 gig based systems, several hundred meters if necessary, whether we use single mode or multi-mode. We can go a far greater distance with fiber than we can with even dream about with copper.
Sure. And it looks like, when you go from OM1 to 2 to 3 to 4, obviously get the distance and the bandwidth. What makes, first, let's clarify what the OM is: optical multi-mode, right?
Correct. Yeah.
So there's a multi-mode cable. What makes 1.1 and 2.2 and 3.3 and 3.4?
In essence, it's the clarity of the glass. During the drawing process, there's a difference in clarity of glass between what you start with compared to what you end with, and so there's actually a fairly technical explanation as to the specifics behind this. But in essence, it's the clarity of the glass that's going to cause the specification of the glass to be able to carry a slightly greater bandwidth over a slightly greater distance.
So the clearer, the more pure the glass is, the further the photons can pass through and get to the other end.
Effectively speaking, yeah.
And it almost seems like it's like looking through a really clear piece of glass, and the picture on the other side is clear versus a foggy piece of glass or a scratched up piece of glass, right?
In very basic terms, yeah.
Gotcha.
As a very basic explanation, that's kind of the way it works. Yeah.
Good. Cool. Awesome. That's great.
So let me see. I think I've got a couple of extra slides here that I'd like to just show you real quick.
Sure.
First of all, as we start talking more about fiber, you've got to understand that there's multiple layers to fiber optic. Down at the very center, you remember me mentioning that the glass core, and as I said, that's a 9 micron core in the case of single mode, or 50 micron core in the case of multi-mode. Around that is that cladding. You remember I used the analogy of the golf club in the lake trying to get your golf ball out. Well, that glass cladding is basically, for all intents and purposes, a mirror. It causes the light to bounce down the core rather than out to space.
So the light stays in and bounces in the core and not out into the atmosphere.
That's right. That's right. Exactly. And there's several layers above that, and they're purely there to build up strength and protection of the glass core and cladding underneath them. You'll see there's a coating there which is called an acrylate. There's an acrylate which, to give some numbers to it, that's normally a 250 micron acrylate, and that acrylate is there again to build up strength and protection, and that would require being stripped off using a pair of fiber calibrated strippers. We'll talk about those in just a second, and it has to be stripped back to a very specific length depending on the connector you're using, so that only a limited amount of the cladding is exposed to the elements, to the atmosphere. Do you remember we spoke about earlier the atmospheric environment and how fiber is very resilient to it? Well, in actual fact, glass is very, very intolerant of moisture and liquid and contaminants from the air. And so when we're talking about a pure glass like this, we want to reduce the number of contaminants and the amount of exposure that this glass has to any moisture and humidity and contaminants. So in stripping back the fiber ready to terminate, you want to actually strip back these these layers to a very precise amount. Otherwise, you're going to expose that cladding to the elements after termination, and eventually, the moisture, humidity, and contaminants from the air, they can actually break the glass down and cause it to fail. So the measurements that you're stripping these different layers back are very, very precise in order to allow for a proper termination and have that fiber be protected from all the outside stuff that goes on. So that's the coating or the acrylate. Generally, there's another 900 micron buffer jacket around that, which is if you think about it, 900 microns is actually just shy of 1 millimeter. So even though we're considerably bigger now than the core and the cladding, we're still only dealing with a medium that's 1 millimeter in diameter. So very, very small.
That's cool.
Above that, We've got these strengthening fibers. They're generally made of Kevlar or aramid yarns, and they are there to pull the fiber or to install the fiber with. You don't want to be stretching the fiber and pulling on it with the jacket. These aramid yarns are there to actually pull the fiber during installation.
So when
and they look like little orange hairs, basically, but they're extremely strong. Kevlar is actually the same stuff that they make bulletproof vests from. So, you've literally got some bulletproof protection around that glass at this point.
So a good tech tip might be, pull the Kevlar, not the cable.
Yeah, I mean, we generally say, strip back the outside jacket about 6 or 8 inches, and then just separate the Kevlar yarns from the cable and make a loop out of that. Tighten a knot, make a loop, and then you can pull the Kevlar as opposed to pulling the fiber itself.
And because it's Kevlar, you could probably pull it as hard as you want.
Pretty much. I mean, the tolerance of ours is well over 200 pounds.
Oh wow!
So you can really tug on that thing, and at the end of the day, I mean, it could potentially be stronger than you are, but
totally, yeah.
You don't want to be playing tug of war with it. But I've seen situations where it's undergone some real stress, and the Kevlar has actually survived really well. And so has the fiber underneath it. It's generally the jacket that gets stretched after that.
I can almost picture, like in the manufacturing process or in the lab somewhere, there's like some machine they've built to pull apart to see where it breaks, how strong that has to be for it to break.
Right. Exactly.
Yeah,
exactly.
That's really cool. Now, one thing I do notice, the jacket on this cable on your PowerPoint is orange. The jacket on the cable you were holding in your hand earlier was like a teal color. Does the color of the jacket indicate anything?
It does. Now, if we go back to this slide here, the OM 1, 2, 3, and 4 are color indicated. So if you see a teal colored or aqua colored cable, it's probably going to be an OM 3 cable. OM 2 is generally orange, and then OM 4 is more of a purple color. The color coding of the jacketing is generally OM 2 being orange, OM 3 being aqua, and then OM 4 being a magenta or purpley color. And then in the case of single mode, it's generally yellow.
It's all single modes yellow usually?
Correct.
Cool.
Yeah, exactly.
Is there like a general rule of thumb or a general practice, like if you're wiring a home or a restaurant or something like that, is it safe to say, like, just do OM3? Like, it's going to be plenty, the clarity is going to be plenty good, the bandwidth's going to be plenty good, or is there still a use case for long distances for, like, I know you said 1's kind of obsolete now, but what about 2?
No, 2 is actually a lot of the HDMI cables that utilize fiber in them are actually an OM2 grade fiber. The hardware that you're plugging into it is generally going to stipulate what you're going to need to install in order to achieve the results you want to achieve. If you look at the specs for a fiber-based device, it will say, we can perform to this specification or to this standard using OM2, or we can do this using OM3, or we can do that using OM4. It's really contingent upon the hardware that you're plugging into it as to what it can perform to.
Good. Okay, cool. Thanks.
So this is a conventional fiber that we're looking at here. I'd like to switch to this screen because you can actually see some notable differences here. Clearline fiber is fundamentally the same at the core level. Okay, it's very important to realize that if you look at the numbers here, we're still at that 9/125 or 50/125. So that core diameter is still exactly the same as standard fiber optic cable, meaning that our fiber can actually be used with anybody's connectors. In actual fact, our connectors can be used with anybody's cable, because those numbers there, the 9/125 and the 50/125, those are standard industry numbers. So we still conform to that as far as the core is concerned. But what you'll notice is, we actually reduce the size of our cladding by about 10 microns. And so we reduce the cladding down to about 115 microns, and then we build it back up again with the SSF polymer. And the SSF polymer is the secret sauce. It's kind of the proprietary part of what Clearline has created here. And that polymer never gets removed from the glass cladding. So you remember in a previous slide, I told you that we have to strip back all those multiple layers to a very specific length. Well, that's not the case for the polymer. The polymer remains around the cladding. It protects the cladding from any moisture, humidity. ingress of dirt. It gives it a lot more strength. But more importantly, it also makes it very, very safe. All right. So you can quickly and easily train somebody to use this and not worry about them potentially, puncturing their skin with the glass at this point. Because realize you're dealing with needle-sized pieces of glass here, which in a conventional format can easily puncture skin, and if you get glass in your bloodstream, it's really not cool.
Yeah, it sounds bad. But it sounds like you're really, because of that, you're not ever even touching the core, huh?
You're not, other than at the tip. When we get into this and we start looking at the termination, you'll see that we have to what's called cleave the end to give a nice 90-degree lens, a nice clean lens to the core. No, until that point, the polymer is completely protecting all of the glass underneath it. So there's no exposure to any contaminants from the air. It's completely safe to handle and makes it incredibly strong. And that kind of leads me on to the next point, that the obvious difference to these diagrams is that, we don't need that 900 micron buffer jacket that I mentioned earlier. With a conventional cable, we've got that 250 micron hard acrylate around the cladding. And then we have a 900 micron buffer jacket. And then we would have those Kevlar aramid yarns. And then we would have the outside jacket around that. We don't need that 900 micron buffer simply because the fiber is made strong enough and protected enough by the SSF polymer that we can actually get rid of that layer completely.
The SSF polymer is really the hero here. It's protecting the installer. It's protecting the glass. It's making it to where the cable can be smaller. I would only guess it's some sort of secret sauce, some sort of really interesting material.
It is.
Need less of it instead of the whatever material the 900 micron buffer is made out of. This is really cool. This is really cool stuff.
Yeah. So the other difference here is you'll notice the 250 micron layer. On the right-hand side, you can see that it's a hard acrylate on a conventional fiber versus a soft peel acrylate from ours. You can literally peel our acrylate, that layer of acrylate, you can peel that off between finger and thumb. In fact, you shouldn't use strippers. If you use the strippers, you can potentially damage the polymer underneath it.
Oh, you could probably nick it or something, yeah.
Yeah, exactly. So, whereas you would have to use a pair of strippers for the 250 micron hard acrylate on a legacy or a traditional fiber. And if you don't practice that each day, it can actually become, quite tedious because you can break that cladding and break that fiber very, very easily, realizing that you're dealing with something that's incredibly small. So the ability to peel that soft peel off between finger and thumb, or if you don't have fingernails, you can actually use a plastic credit card on a flat, table surface or something like that. It's really simple to pull that soft peel acrylate off just to bring the polymer to the forefront, and then that's the point at which you would cleave the fiber to the correct length for the connector.
Very cool. That's awesome.
All right, so now we've gone over some fundamentals of fiber and how it works and why we would even need to be talking about deploying fiber. Jason, if we can, let's talk a little bit about how easy it is to terminate, in particular, clearline fiber, because it really does overcome a lot of the challenges of terminating, legacy or traditional fiber. As I mentioned before, the tooling was always very expensive. People had to go on very expensive training classes to be taught how to handle the fiber. They have to be careful with bend radius and things like that. And it's actually a very expensive process, and the training can be quite time consuming.
Sounds like it's some kind of certification you might even need.
Exactly. And so all of that is really kind of overcome with Clearline because of that polymer that we incorporate, around the glass. It makes it safe to handle. It makes it easy to terminate and strong to pull. So you really don't need that training.
Yeah.
So what we're going to be talking about today.
This is my kit. This is it.
Yep, there we go. So yeah, I've got the newer version of that.
Oh, you have the hard kit. Very nice.
We actually did a running change of upgrading the little Canon camera bag to a hardback case.
Nice, I like that.
But fundamentally, they're the same inside. So if we open that up, one of the advantages is Clearline is we were able to reduce the tooling to a very minimal amount. All right, so you'll see here we've got a pair of Kevlar shears. That's what's necessary to cut those Kevlar yarns. You cannot use regular cutters or strippers or scissors because you just end up getting frustrated with it. Kevlar is incredibly strong, so you need special shears for that.
These are probably scissors that you want to be very careful around.
Yes, yeah, you can easily cut yourself with those, so do be careful. Next online here is you've got these strippers. Now, if I hold that close to the camera, you can see these strippers actually have 3 calibrated holes inside them. And so the outside one is what you would use to strip the outside jacket. And then do you remember, Jason, I told you that with regular fiber, you have to strip down, the 900 micron buffer jacket, and then you have to strip the 250 micron acrylate. That's what those various holes are for. And as you can see, they're pretty darn small. If you're not practicing the stripping of fiber every day or several times a week, you can quite easily go ahead and break that fiber because the delicacy here is quite intimate. So
these are calibrated or tooled to be extremely precise, right? So you wouldn't want to just go use any old wire stripper.
No, you need to use fiber calibrated strippers for sure.
So the first hole is the biggest hole. That's probably to get the jacket, right?
That's right. Yeah.
The second hole is quite a bit smaller, and then the third hole might be the polymer itself, or is that what you were talking about with your finger? You could get.
That's right. So the second hole down is what would normally be used to remove the 900 micron buffer jacket that we don't have.
Okay, so we're probably not in the clear line cable. In that case, we're probably not going to use the second hole.
We only use. Yeah, we only use the one hole at the top to remove the outside jacket of the fiber in the case of a 3mm jacket. The next hole down, the 900 micron, we don't need that because we don't have a 900 micron buffer. And the next hole, the smallest one of the 3, is a 250 micron hole. And again, we were able to produce a soft peel acrylate. And so that soft peel doesn't even require the use of these strippers because that's at the point where we can just use finger and thumb to take our acrylate. So These strippers are really only here to just remove that one outside jacket, the 3mm jacket on the outside.
Good, easy enough. That's great.
And then in the box we've got what we call a cleave tool here. The cleaver here is the device that's actually going to cut the fiber, and it's going to cut it to the correct length for the connector that we're using. And it's also going to provide it with a nice polished, shiny 90-degree lens on the end of it. That's the cleave tool. That's a very important piece of the kit. We've also got here a VFL. It's kind of like a flashlight. A VFL is a visual fault locator. And that's basically just a light source that we're going to shine down the piece of fiber, and it helps with the termination process. So you're able to see what you're doing rather than kind of do it in the dark.
And that seems to be a laser, so don't look in it.
Yeah, don't look down it. You can shine into the camera because the camera can't reproduce that, but you don't want to be looking straight down.
Please look at laser with remaining good eye.
Exactly. And then finally, we've got just a little garbage can, a little pot here that we use for any offcuts of fiber and the jackets here. And then in the new kits, we've got this little section here, and that's used primarily for just storage of spare batteries for the VFL. All right. It does take 2 AA batteries.
2 AA?
Yeah, so you can use, I think the AA. In the new ones, they're 2 AA batteries. And so we can store some spares in there as well.
This might be a good time, Gary, to talk about the different ends. My kit has this little adapter in it.
Yeah. So that little adapter is there because the end of the VFL at the end here, that's sized for what's called an SC connector. The SC connector is this square guy, right? The SC connector is used again for certain types of hardware. Sometimes manufacturers of the hardware require an SC connector. Sometimes they will use the smaller LC connector that we referred to earlier. And that adapter is there to adapt from the SC to the LC size.
So the LC are the smaller of the 2 types.
Correct, yeah. You can always remember it because SC is square.
Right.
And LC, although the L actually is lucent, some people refer to that as little. So little connector.
Which connector fits natively on the fault locator?
The SC connector.
The SC. So this adapter goes SC to LC.
Correct.
And there's 2 little caps. I probably need to remove both of those, right?
You do. Those are dust caps. Remember, we're dealing with something that's very, very sensitive to dirt and moisture. So all of the connectors and the adapter and the VFL here, they all come with caps on them. And you want to try and keep the caps on the end of the tips as much as you can, just to try and keep any dust and dirt away from those lenses.
So a proper kit is going to have the Kevlar shears, the calibrated strippers, the cleaver, the visual fault locator, and the adapter to go from SC to LC on the visual fault locator, and the little trash can for all your garbage.
That's right. Exactly.
So this all comes in a nice little kit. I have an older one that's a soft case. You have the new hard case.
That's right.
Gary,
you can see it here. It's got clear line written on it.
What's MSRP on a kit like this?
MSRP off the top of my head, I think is about 800. You're going to be looking at a dealer price, obviously, that's considerably less than that. But for the purposes of this, we'll leave that to your individual salesperson to let you know what the dealer prices are.
So we're talking now a kit that you can buy for easily under $1,000.
Absolutely,
definitely under $1,000, and it's going to have all the necessary tools you need to terminate fiber on the job site.
Sure, that's awesome. Exactly right.
That's exactly right. Cool, great. Good. That's great. I have a piece of fiber here that I'm going to be kind of practicing with and going along with you.
Okay.
One thing I'm not quite sure about, the fiber that we were looking at in the slides and whatnot were all like just one single piece. The piece that I have is actually two pieces of fiber.
Right. So that's a duplex. So you remember we explained the difference between single mode or multi-mode?
Right.
Well, that applies to each strand of glass, each strand of fiber. That's the difference between one beam of light going down that glass or multiple beams of light. Now, in the case of duplex, you've got two of those. So I actually have here a piece of simplex. So I've just got one strand of fiber.
Yeah,
in this case, it's right. Okay, so this is aqua, right? So that tells me that it's OM3 multi-mode.
Right.
All right. And so this is only one of them. So that's a simplex piece, and then just two of them together, kind of like a shotgun or two fused together.
Sure.
You can see there is a duplex. And then when we start talking about multiple strands, underneath the same jacket, and I have a piece here. Underneath the same jacket, this would be called a micro distribution fiber. So you can see we've got multiple fibers, in this case 12, underneath that same jacket.
So if you're running cable to a room that has I'm thinking maybe a video wall in a conference center or something, where you might need to get signal to, more than one display, then you can either go with, do they make it bigger than duplex? Do they make it bigger than just two?
The duplex is just always two, but then you've got the multi-strand, what we call the micro distribution.
Okay.
So you
but that's still in one jacket, it looks like.
It is correct.
Good.
Yeah.
Cool. Good.
Exactly. Yeah.
And then there's like 6, I think, in each one of those.
Yeah, you can do either a 6-strand or a 12-strand, or if you're feeling really ambitious, just to give you an idea. This guy here is a 72-strand fiber.
Oh, that's awesome. That's really cool.
Right. So you got 72 strands of fiber in something that's realistically not much bigger than a piece of Cat 6.
That's crazy.
Just to give you an idea, that's 72, equivalent to running 72 Cat 6As in that little tiny cable.
Wow. So that's like maybe a data center or a casino or something crazy like that. That's really cool.
Exactly.
Good. Awesome.
Exactly.
All right. I'm going to use, just for the to practice here with you, I'm just going to use my simplex cable.
Yep, no problem. Yeah.
Let me lop the ends off here. There's still ends on there from last time we were practicing.
All right. Well, one point to note about this at this point is that you can actually reuse the connectors we're going to be showing you today.
Oh, nice.
Yeah. So the clear line connectors, you can use them realistically 4 or 5 times. So if you make a mistake during termination, you can just cut them off as Jason is doing there and start from the beginning. But honestly speaking, we've used them for demonstrations at trade shows and such like, and we can still shine light through these things, after several dozen terminations. So
that's great.
They're pretty durable.
What's going on under the hood to make them reusable? That's pretty cool.
Yeah, basically there's no crimp at the end. Normally with fiber connectors, you've got some kind of crimp at the end where the cable goes into the back. We don't have that crimp, so we'll talk about that in just a second. But we don't have that crimp because that crimp becomes a permanent fixture at that point. And what we have in here, if I can show you, is in actual fact I'll use an SC connector because it's a little more easy to see. In the end of the the connector here, there's actually a piece of factory installed glass that goes into the tip. All right. And that itself has got a nicely polished end to it, that piece of fiber. And then in that yellow window there, within that space, there's actually what they call an index matching gel. And so what we're going to do is when we terminate, we're going to bring these two pieces of fiber. So this is the fiber that's in the end of my connector already, nicely polished at the end with a nice clean lens. I'm going to bring my fiber into it, and I'm going to join those two pieces of fiber together and lock them in place. and that index matching gel helps to make that connection good. All right, so there's actually no physical crimping at the back end of the connector. So if need be, we can uninstall this and kind of redo it again up to 4 or 5 times.
And what happens? Like you insert, reinsert, insert, reinsert, does it eat away at that gel?
It kind of does, and sometimes you can see it in actual fact. If you pull the fiber out, sometimes there's a little microscopic piece of gel, a little globule of gel on the end, and each time you pull it out, it just compromises that connector a little bit further.
Gotcha. Cool. Very cool.
All right, so I think for the purposes of this, we're gonna terminate an SC connector, just because it's a little bit easier for you to see. They're a bit bigger.
Okay.
Not quite so fiddly as the LC.
I've only got LCs here. Is the process the same?
It is exactly the same. The only difference is the cleave length, and we'll talk about that in a second.
Okay, great.
So as we look at an SC connector, as you can see, it's square. And it has the tip on the end here, which comes with a dust cap over the top of it. So out of the packet, the SC connector comes looking like that. And it's got this removable cap. So the aqua, again, we're using multi-mode. So the aqua cap here suggests to us that we need to be using multi-mode cable. And I need to pull that cap off, right, just to expose underneath here the orange window. So you can see there's an orange window there. And that's an indicator window that's going to tell us when we make that connection of the 2 pieces of fiber.
Oh, that's what lets you know. Okay.
Exactly.
On the the LC, I don't need to pull the.
No, the LC connector doesn't have that little cap.
Okay.
Cool. On the LC connector, the orientation of the connector going into the hardware is dictated by the clip at the top.
Oh,
right?
I see.
So there's a clip at the top. The SC connector doesn't have that. So if you look at the cover of the SC connector, there's actually a key on the one side.
Oh, it can only go in one way then.
So it can only go on one way and insert it into the hardware one way.
Cool.
Yeah.
Easy.
So the first thing to remember, you said you're going to do LC, so I'll do an LC with you.
Okay.
So remove the boot from the connector. That's the very first thing you need to do.
This was Gary. This one was already terminated on the cable. So yep. I just took it off. I cut it off, and then I unscrewed the boot and pulled all the excess out. I did notice since
you want to make sure in doing that you want to make sure that the switch, there's a little orange switch here. That's exactly. You want to make sure that's in the open position towards the back of the connector. Okay.
And should I put it back in the forward position when I'm done removing it?
No, because we need to leave that switch open so that we can get the new piece of fiber in there.
So when I'm removing an already used end, I need to open the switch and then pull the cable off.
That's right.
Perfect.
That's right.
Got it.
But they come new out of the packet in the open.
Oh, they're like that, brand new in the box. Okay,
correct.
Great. Thank you.
All right. So take your boot off the connector.
Yep.
And feed it, backwards onto the piece of fiber.
Got it.
Preferably with the jacket still intact. We don't want to do anything with the jacket yet because we could still damage the end.
We might end up having to do it a second time or whatever.
So now we want to take the strippers.
Those are the ones with the red.
Right, so take the orange handled strippers, 3 calibrated holes,
mm-hmm.
and there's no precise measurement involved, just 3 or 4 inches back. Just nip it once with the largest of the 3 holes.
Got it.
And then you can pull the jacket off, very simply.
Got it.
All right.
Sweet.
And so what you'll see here is those Kevlar. You can put the strippers away now, by the way. We don't need those again. You can put those back in your case. So what we have here now is 3 or 4 inches of the Kevlar and the single strand of fiber in there. And as you can see, Jason, if you flick it, you can kind of move those fibers away, the strands of Kevlar away, and just pull those back. So you don't need those right now.
Gary, it looks like you've maybe already hooked up the VFF on the other end.
Yeah, I do. I have a pre-terminated end, which I did earlier, so I've got light coming out the end.
Great.
But what I'll do is, once we've done this, I'll show you how to do the first termination as well.
Perfect. Okay, so the Kevlar, I peeled, kind of separated it from the fiber.
Yeah, you want to separate that from the fiber, kind of twist it together and keep it all bundled up.
I shouldn't cut it or anything?
Pardon?
I shouldn't cut the Kevlar at this point?
No, not at this point. Don't need to cut that at this point because that actually becomes incorporated into the back of the connector to add strength to the termination.
Great.
All right, so now we're at this point. You just want to hold kind of the end of the jacket with your left hand if you're right-handed.
Mm-hmm.
But now this is where we get onto that soft peel. And again, there's no precise measurement here. You can see in your case you've got a blue strand inside. I've got an orange strand.
Yeah.
in a multiple strand, fiber, you can see that we actually use different colors.
Sure.
The strands within each multi-strand or micro distribution fiber are different colors, so you can tell which one's which.
So if you terminate green on one end, make sure you terminate green on the other end,
Sure.
in the basement or wherever you're at.
Exactly. So what we're going to do here, this is the 250 micron soft peel acrylate. All right. This must not be confused with the polymer. This is not the polymer itself.
The polymer is under that.
The polymer is underneath it, right? So remember, the polymer never gets removed. So what we're going to be doing here is just removing the acrylate by gently nipping it between your finger and thumb, using your thumbnail and the pad of your finger, and you just want to start scratching that back, and you'll feel it start to scratch back.
Yep.
You'll feel it start to peel away. All right. You don't want to do nail to nail because you could potentially cleave the fiber. And
it's like nail to finger skin.
Yeah, exactly. So just kind of start scratching that back and remove that all the way to the end, and it just comes off like a little plastic cover.
Yeah. So there's no way. I guess what's stopping you from accidentally removing the polymer?
Because it's just on the fiber too tight. You've actually got to use a pair of strippers to actually pull it.
Some kind of really special tool?
Well, not really. What you would do is, in actual fact, you would use the 250 micron hole in the strippers.
Gotcha.
Actually, just angle it very slightly and kind of scratch the polymer off. But you don't want to do that.
You don't need to do that here.
Well, you would only do that if you're fusion splicing, and for the purposes of this session, we're not going to be talking about fusion splicing. These connectors are not fusion spliced; they're mechanical connectors, right? So now we're down to this point. We're at that 125 microns, including that polymer, right? So you can see here that I don't need to clean it with alcohol. Normally, I would have to clean this with alcohol. It's like touching a halogen lamp.
Or your oil, yeah.
You get the grease and your oils from your fingers. You need to clean that. The other thing to note is we've not really paid too much attention to very precise measurements from the jacket down to the buffer or the acrylate down to the cladding. We've not had to pay any attention to that. We've really just stripped off that outside jacket and peeled off that acrylate. Yeah. So, if we're not walking through this and talking about it, we can do that in a matter of, 10 seconds.
This has been 3 steps max.
Right. Exactly.
Great.
So what we're going to do now, though, what we do have to do is cut the fiber to the correct length.
Okay.
And that's where we actually use the cleaver. And that precision wheel cleaver is Jason, when you cut glass, if somebody takes a sheet of glass, they run a diamond tip along it and then snap it.
Yeah.
That's kind of what this cleaver does. It takes that fiber, it puts tension across it, and it at a very detailed level, it just scores the glass very slightly and then snaps it at an exact 90-degree angle.
So you get a perfect cut.
Exactly. So for the LC connector that we're terminating, we need to do that at 24 millimeters. So that's just one measurement from the outside jacket, not from the acrylate. You might have a little bit of the acrylate sticking out the end. Mm-hmm. If there's a millimeter or two there, that doesn't matter. So from the end of the jacket, right, we want to cleave this to 24 millimeters. So if I can move my camera down so you can see what I'm doing.
Oh, that's great. Yeah, that's perfect.
You want to lay the fiber down into, you can see here, part of the reason I use the light is so you can see this. You can see here there's a groove, right? So there's actually a very slight groove in the can you see that?
Gary, turn the cleaver towards the camera so we can see the markings and whatnot. Maybe towards the middle of the shot too.
Can you see that? It's very difficult. I can't see what I'm looking at. There we go.
That's okay.
So right there, there's a little groove in the cleaver.
Right.
And you can see here there's a ruler here. So for this LC connector, it's important for us to cleave at 24 millimeters. And don't worry, that you don't have to remember that length. It's written on the instructions in the packet. When you buy the connectors, they come in packs of 10 and there's instructions on there.
Oh, great.
So this connector requires a 24 millimeter cleave. All right. And that distance is the distance from the end of the jacket to the point which we're going to cut it.
Sure.
So what we're going to do here, and this becomes difficult on camera, we're going to lay the fiber down into the in fact, I'll try and do it backwards for you so you can see. We're going to lay the fiber down. Can you see that in the camera?
Yes.
and you want to kind of hold the fiber down at an angle because you want to lay it in that groove and have it be flat across those two plates.
Yeah, there's definitely like a groove. There's definitely a groove for the cable to kind of sit in.
Yeah, exactly. So you want to kind of apply a little bit of pressure from the upward position. So you're kind of holding it downwards. You're not holding it flat. If you hold it flat like that, like I'm showing you,
right,
sometimes the fiber can kind of stick up in the air.
I see that, yeah.
Right, so you want to hold it from above, really, and just apply a little bit of pressure in that groove so that that fiber lays flat across those two black plates right
Perfect.
there.
Yeah, I got it.
All right, and just move it along so that the jacket, the very outside jacket, is at the 24 millimeter point.
Got it.
All right, so now what we're going to do is we're going to close the cleaver, and we're going to push the button on the bottom. All right, now you can go ahead and open the cleaver again.
Okay.
All right. Now you see that it's cut to 24 millimeters.
I've got this piece that you probably can't even see on my camera because it's so thin.
So here's the thing, guys. With clear line fiber, you don't need to worry about that offcut, that shard of glass that you just cut. You don't need to worry too much about that because it cannot penetrate your skin, right? So if you look at this, you can just about see, I think. You know, I'm
barely
poke my skin with it, and it's unable to puncture my skin. So if you do happen to misplace this and it goes into carpet or in your clothing, yeah, it's going to scratch a little bit, but it's not going to puncture the skin and cause any damage. However, it is good practice to put it in the little garbage pot. So we're going to put that in the garbage pot and close that up. So now at this point, you don't want to touch the end. The reason being, you remember we made a nice
with your oil,
a nice lens to that at the end of the fiber. You can still touch the side if you happen to misplace this and drop it. You're up a ladder, or you happen to drop it onto a surface that's not quite clean. You can still touch the side, right? The side is protected by that polymer.
Sure.
So again, we're trying to save some time here in the preparation by just allowing you to realistically use this in an environment where it's not necessarily sterile, it's not necessarily perfectly clean. The reality is you might drop this onto a surface that will get dirty, but it doesn't matter. But you do want to try and protect that tip.
Good
all right?
Good call.
So what we're going to do now is we're actually going to take the fiber, and you want to hold the very end of the jacket. And the reason I say that is because it kind of becomes a bit of a three-handed job at this point. You want to hold the end of the jacket and the connector in the other hand, and you want to open the back of the crocodile clip on the connector, right? And now you want to insert that fiber, just slide it down the channel. And what you'll notice, if I do mine first, what you'll notice is, as I do that, the light by my thumb there kind of travels down that window. Hold on. Kind of trying to do this with the camera in mind as well. So the light kind of travels down that window by my thumb.
Yeah.
Right. So you can see there that the window goes dark.
Right. No light, and then there's light, and then when you push it in further, there's no light.
And I want to actually push it in. You can probably see just slightly that I've actually got a slight bow of the fiber.
Oh, yeah.
So, and I want to use my one hand to keep that bow there.
Okay.
Right, because I'm actually going to push my fiber in, and you remember I'm pushing those two pieces of fiber in, and I want to hold it in place.
Sure.
All right, because then what I'm going to do, while that remains dark, I want to slide that switch to the closed position.
Gotcha.
Okay.
Got it.
So now let me show you something. So if you relaxed that very slightly, if I relax that fiber back, you can see the light has come back on in my window.
Right.
Right, that's a poor connection. I don't want that to be the case.
Okay.
Right? That indicator window is very important. So you want to make sure you hold it in place and then lock it, and that window should remain dark.
Okay, got it. Yeah.
All right, cool. Now you want to just kind of relax the fiber down in the back. Make sure the fiber is not overlapping the crocodile clip and gets trapped in the crocodile clip. Pull the Kevlar off to one side. Just relax the fiber down, and you'll see there's a little channel there that the fiber sits in. Right? So lay the fiber down, and then just close the crocodile clip, and you should be able to gather all the Kevlar off to the one side.
Got it.
All right? And then you want to grab that boot that you pre-threaded onto the end of the fiber. Bring it up, Now with the LC connectors, it's a bit tight just because it's so small, but you should be able to close that crocodile clip down and twist that boot a couple of turns and just capture the Kevlar into the thread of the connector there.
Oh, just so it gets caught in there?
Yeah.
Cool.
All right. And then you want to just trim the Kevlar off again. Use the Kevlar shears. They're incredibly sharp. Please be careful. Just trim that Kevlar off right to the surface of the connector.
I can only imagine with some practice this gets easier and cleaner and...
It does, yeah. You get into a routine.
Sure.
And then just finish tightening the cap down. It's going to squeak a little bit on these LC connectors, but tighten that cap down just to cover up the rest of the Kevlar there.
Oh. Throw that Kevlar away. And then I think I've already got mine pretty tight. Oh yeah, mine's tight.
There you go.
Good.
So now the only thing to do now is you want to take the dust cap if it's not on there, and you just want to make sure that dust cap is on the end. Like I said, you want to try and keep your dust caps on as much as you can.
Sure. Okay, good.
And that's your termination done.
All right.
So now, I mean, there's a little bit of magic that goes on with Clearline here. So, you know, we've done our termination, but just to give folks an indication of how strong it is, I'm going to tie this piece in a knot. So I'm literally tying this in a knot here, like so. I can really tie that into a knot very tight, and you can see the fiber underneath is not breaking.
Oh, great. So I'm thinking like you're in an attic or whatever, crawl space maybe, and you've got to maybe wrap this thing around something. Like, that's not a worry.
Yeah, no, absolutely. You can go through stud bays. You can go, you know, if it gets kinked, obviously that's not ideal, but it's not going to break. You can actually kink this product, and, you know, it's not preferred to leave it kinked, but if it does get compromised during installation, it's not going to actually break very easily. Yeah.
Okay, let me throw my adapter on here for my LC, on my fault locator, VFL, right? Visual fault.
Visual fault locator. That's right. Mm-hmm.
Okay. So let's put that into that. Does it screw down?
No, it doesn't. No, I mean a lot of these tools they're universal, right? So the adapter might fit different types of VFL.
Gotcha.
And that's another thing to consider with Clearline is that none of the tooling is proprietary. It's all off-the-shelf tooling. Now, we make it nice and convenient in the kit for a very affordable amount, but you know, it's really standard stuff. Where there's nothing proprietary about what we're showing you other than the fiber itself.
Gotcha. Okay, cool. So these are all common things.
Sure.
So I terminated the one end with your help, and my other end I've got light.
There you go.
Is there a way? Should the light look a certain way, or is it just light or no light?
At this point, it's just light or no light. Cool. I mean, once you cleave it, you'll get a nicer beam of light coming out once you cleave it. Mm-hmm. But at this point, you've just cut that with the shears. You've taken that off. Yeah,
because right? You can tell right now that it's the light is very almost like scattered.
Yeah, exactly. Because you've shattered the end of that glass. There's no clean lens to it. You've shattered the end of it.
I gotcha. I think maybe when I lay the VFL down, I think there's a connection being lost because I lose the light. Maybe my termination wasn't perfect, but I don't know if...
No, you can. I see it. I've not seen it. Yep, absolutely.
Yeah, the light's very spread out, so that makes sense.
That's right, because you've shattered the end of that glass.
Shattered. Yeah. Okay. Cool.
That's why it's important to use the precision wheel cleaver when you come to terminate.
Right. I did notice something with the cleaver I wanted to ask you about. When we laid the cable down into the channel and measured it at 24, we have to close that little black door, or is that not necessary?
It's not essential. That's actually there to hold again, these are all standard tools, right?
Right.
So remember, we have that 900 micron buffer jacket in some cases where you're using legacy fiber. That's used to hold that 900 micron buffer down.
Okay.
So in actual fact, we don't need that because our fiber almost kind of slides underneath that.
Kind of just fits. Yeah.
Yeah. So it's actually not imperative to use that.
Is there any calibration or anything to this cleaver that anyone would need to know about in the field?
So yeah, if you buy the kits from us from Clearline. The cleaver comes calibrated specifically for Clearline fiber.
Gotcha.
And what I mean by that is the blade is actually raised very, very slightly by 5 microns just to score through that polymer. All right. So imagine you're cutting through that polymer. A standard blade would be reduced in height and actually wouldn't actually cut that polymer. So the blades come calibrated out of our kits, but if you've already got cleavers out there, we can actually walk you through the calibration. It's a very simple process.
Okay.
We just need the make and the model number of the cleaver, and we can show you how to calibrate it. It's real simple.
But the kit that we sell with the clear lines already pre-calibrated, no worries.
Sure.
If I drop it or something by mistake, will it knock the calibration out, or?
It shouldn't do. No, I mean this. Okay. This is our basic, more simple kit. If you're using fiber regularly, and you're likely to have more opportunity to drop it, we actually make a pro kit, which has a heavier duty cleaver in it. So if you're using more of an, although these cleavers are useful for several thousand cleaves, as long as you don't drop it and break it and such like. Incidentally, if you do run into a job site where there's legacy fiber that's not clear line, you can use all this tooling on those fibers as well, right? So you can use our connectors, you can use our cleaver and such like. They're all available. Like I said, all the tooling is standard.
So if I'm an integrator right now and I want to start doing fiber, I basically need to buy the fiber in whatever amount spool I want.
Mm-hmm.
I need to buy either the LC or the SC ends.
Correct.
To terminate with, and the kit.
That's right. The kit's a good starting point. The fiber, generally speaking, in a residence, we're dealing with primarily duplex fiber. So anywhere that goes from sort of a rack unit to a display, you might want to pull at least a duplex fiber, so 2 strands of fiber. Preferably 4, that would be ideal. So you can pull 2 duplexes or a 4-strand fiber to an access point, for instance, for future use of a gigabit access point. You might want to use again a duplex or two duplexes between racks. If you've got a bigger job where you've got racks, you might want to pull 6 or even 12 strands of fiber between the racks.
Okay.
But generally speaking, there's no strict rule of thumb. This is just input given to us, over the years and seeing how fiber's been deployed. But what's important to note as well is that there's I've lost my train of thought. What was I going to say about that?
We were talking about like what the installers need to get started to. So the
connectors that they buy. So you've got the basic kit. The connectors that they buy is going to be stipulated by the hardware they're using. Again, an SFP like this is using 2 LC connectors with a piece of duplex.
And
right?
If I'm not mistaken, in the 2 AVPro pieces that we have available right now, those are LC.
Correct.
Okay, good.
Yeah, they are. Yeah, they both take a single LC connector. Other manufacturers, I think a lot of AV manufacturers like Crestron and Savant, they use SC connectors simply because they've got the room in the back of the device to be able to provide you.
Got a big,
they've got a bigger chassis, right? So you'll find that the LC connectors are generally used in applications where there's not much space because they're small, right? They're little.
Yeah.
So that's why they're used.
And is there a way to, let's say somebody shows up to a retrofit type of installation and the products they need, the products they're going to use have LC, but they were already field terminated. The cables are field terminated with SC. Is there some sort of SC to LC adapter? Or
there are
lop it off and re-terminate?
No, there are adapters out there, but generally one would use a coupler, which would basically couple the end of the LC, and then you would use a patch cable, which could be an LC connector on one end and an SC connector on the other end.
Or what might even be easier than that and more cost effective is just lop the end off and re-terminate an LC and you're done.
If it's field terminatable fiber, yeah. If it's our fiber, you've got no problem doing that. But a lot of the fiber out there cannot be field terminated.
So I want to do 2 more things with you, Gary, and then we'll wrap up for the day. We went through a great demonstration and explanation of how to do the termination step by step and explaining each step and this and that. I want to prove to everybody that this can be done in a minute or less. Mm-hmm. So if you could maybe aim the camera down to how you were showing the cleaver before.
Sure.
And let's see somebody who's done this a lot do one from scratch. And I will run my stopwatch here, not to put pressure on you or anything.
Well, thanks.
But I'll run my stopwatch here, and don't rush or anything. I want a good termination, but let's see. Let's see how good you are, man. Okay, so let's go ahead and time you on how fast you can do one, you being somebody with a lot of practice. So I'm going to go ahead and hit start on the stopwatch right now.
All right. So the first thing I'm going to do is insert the boot over the end of the cable here. I'm just going to use the strippers to take off about 3 or 4 inches just use that big hole at the top there to take 3 or 4 inches of the jacket off, kind of flick the fiber away from the Kevlar. Now I'm going to take that 250 micron soft peel just between finger and thumb, begin scratching that back. You'll feel that coming back very quickly there. Now I'm going to cleave that to the correct length. We're using an SC connector today, so this is a 28 millimeter cleave. For ours anyway, it might be different for somebody else's. So now I've cleaved that to the correct length. I'm going to take the SC connector and open the back up, insert the fiber into the connector, and you'll see that the window by my thumb there goes dark once I've introduced the end of the fiber to the fiber in the tip there. So now you can see the light coming out the end. I'm going to close that up so that window remains dark. Lay the fiber down flat in the connector. Now I'm going to gather my Kevlar off to the side, and just a couple of turns of that boot captures that Kevlar into the thread. I can trim that off, finishing doing that boot up. Now I can put my cover on. It goes one way round for the SC connector, and that's me done.
Boom. That's a minute 27 or so.
Okay.
And that's
so I was kind of walking you through that.
Yeah, that's with some explanation. So I can see it being around a minute for the average person after they get some practice. That's fantastic.
Just for fun, I can do it sort of without an explanation, so we can just see how quickly it is if you want. So I've just unterminated my fiber, and I'm just going to, if you want to time me again, just so that we can get to under a minute, we can see if we can do this in under a minute, if you'd like me to do so without explanation.
I'll give you a 3-second countdown, okay?
All right.
3, 2, 1, go. He's flying, folks. Dark window, that's a good sign. Close the window up. Screw the boot on. Cut the excess Kevlar. Screw the rest of the boot on, the rest of the weight rather. Put on your dust cap and put on the end and you're done. 44 seconds. That's great. 44 seconds, man. I could see anybody with some practice being able to do it, do it just as fast. That's fantastic. So cool. That's great, Gary. One final thing I wanted to discuss with you while we're having our session here. So we've talked a lot about fiber, why you should use it as infrastructure, how to terminate it, all that fun stuff. So what does AVPro have to offer if somebody wants to run fiber as their infrastructure? What does AVPro have to offer when it comes to the extender kits themselves?
Well, there's a couple of extenders. There's the uncompressed and the compressed version. Now the EXO 444 is a compressed version. The EXO 444 UNC uncompressed is the uncompressed version, and they can literally extend over a single strand of fiber. They can extend HDMI over actually I think it's up to 7,000 feet with a single mode piece of fiber.
That's awesome.
Using multi-mode, it's a couple thousand meters, so 2 kilometers, about 1.6 miles. So they've got the ability to extend not only compressed and uncompressed HDMI, but also full HDCP and EDID management. There's built-in test patterns for those, so you actually don't have to have a source device attached to the end, so you can calibrate and make sure your infrastructure is done properly prior to the source device being plugged in. You've also got audio return channel and audio breakout. So there's all kinds of neat features in there, including control as well. So you can integrate this into a system as well, and control it with bidirectional IR or RS-232. And in the case of the uncompressed device, the EXO 444 UNC, the uncompressed unit, they've actually got 2 1 gigabit Ethernet ports on the devices as well. So you can feed both uncompressed HDMI and control and audio return channel all over a single piece of fiber, and you're basically installing a media converter as well. So you've got a 1 gigabit Ethernet port as well. So some very cool devices.
You could hardwire one end to your router and then hardwire the other end to your Xbox and TV and whatnot. That way they're hardwired to the network.
Sure.
That's super cool.
Exactly.
And
the other thing I want to talk about with AVPro in particular is, Clearline are beginning to partner more and more with folks out there to try and incorporate the Clearline glass, the Clearline technology into other products as well. This is one of Clearline's, one of AVPro's bullet train active optical cables. You can see it comes with an active optical end to it, so that this is actually fiber optic in here, as well as the strands of copper that go into a regular HDMI cable.
And Gary, does that say source or display?
Yeah, so this is the source end.
Good.
All right, and this is an 18 gigabit per second device, meaning that the chipset in here and the silicon that we use in here is all rated for 18 gig. So that's good for for HDMI 2.0. And you can see here though that I cut the end off, and the reason I cut the end off, you can see that says display on it. The reason I cut the end off is because, thinking about this, guys, when I need to upgrade from HDMI 2.0 to 2.1, 18 gig becomes obsolete. All right, so this head end almost becomes obsolete. So what do? We need to be able to obviously, use the infrastructure rather than try and pull a new HDMI cable. This gives us the ability to actually cut the ends off and actually terminate Clearline connectors or fiber connectors on the end of those 4 strands of fiber. So now we can use an HDMI 2.1 or HDMI 2.2 or HDMI 6.0 version extender down the road. We can terminate those fibers in the field just using the 4 strands of fiber that are already incorporated into the cable. So that's very cool.
That's super cool.
You've really got the ability to install an infrastructure here that initially is a finished HDMI cable, but then when it comes to upgrading your system, you can terminate in the field without having to worry about trying to get that fiber through conduits or back around stud work and stuff like that.
So it really sounds like all these solutions we talked about today are eliminating the whole thing of having to rewire a home every, let's say, 10 years because of changes in technology.
Look, so think about what's happened over the years. It wasn't so long ago that we were talking about running Cat 3 and Cat 5, right?
Totally.
And we thought that everything was great, but then technology moved on and new devices were released, and you'd use the Cat 3 that's installed as a drawstring to pull in your Cat 5,
right? Yep.
Because you needed to upgrade your infrastructure, and then we moved on from there, and it became Cat 6 and Cat 6A, and every time there was a technology shift, you had to upgrade that infrastructure to be able to deploy or deliver that technology. If you're pulling fiber in today, like I said, fiber's been fundamentally the same since the 50s and 60s. It's using light instead of electrical pulses to transmit data. So if you can start getting some fiber into your building now, as well as copper, if you need to. I have an example here, for instance, where people want to be able to run copper, so they've got three Cat 6s here in this bundle, but we've got 2 Clearline fibers in here that can be pulled, they can be ran the same time using this. They call this a Chinese finger torture device. Right? You can pull that as a bundle, right, straight from the spool, and not have to worry about compromising the fiber anymore.
Sure.
All right. So if you want to still pull Cat 5 or Cat 6, that's entirely up to you. It's going to become a little redundant soon, but some people want to do that just because that's what they're used to doing.
Either that, or you just rather be safe than sorry.
Yeah, now with Clearline, you don't have to worry about bend radius.
Right.
You don't have to worry about pulling it too hard, right? Because it's stronger than the Cat 6. All right. The other important thing to note is, if you wanted to, you can pull your fiber cable and you can leave it coiled up in the back box, right?
Oh, sure, yeah.
You couldn't do that with a conventional fiber because the bend radius wouldn't allow you to do that. All right. So if you're pulling fiber today with your bundle of Cat 6, pull a couple of strands of fiber as well, at least, if not two duplexes, and you can leave them coiled up in there, and you can come back to them and terminate them later on down the line when your client needs to.
That's great.
So
that's good stuff.
The ability to pull a bundle like this now with fiber included, without having to worry about it breaking, that's really kind of revolutionary.
That's cool, man. Well, gosh, Gary, we've covered so much today, man. Thank you so much for the lesson, and I'm definitely more clear on how to do the termination stuff now. Like I said, I've tried it a couple times, but having you walk me through it really helps a lot. So any last final thoughts? Anything else that you think we may have missed?
I don't think so.
Perhaps?
I think we covered a lot of ground today.
Yeah, that's great. Okay, cool. Well, thank you so much, Gary. And what do you have next? Do you have? Are you going to be coming to InfoComm in Orlando?
Yep, I'll be at InfoComm, but I think I've got a trip coming up to the UK here again, teaching folks how to use fiber and why.
Great.
Lots of travel coming up, but we'll see you in June in InfoComm.
Yeah, I'll definitely see you at InfoComm. I'm about 90 miles away over here in St. Petersburg. It's in Orlando as usual. So I'll definitely see you in June, man. Thanks a lot for the lesson, and we'll catch up soon.
Awesome. Thanks, Jason. See ya.